Need to authenticate with FastMCP, but worried about getting the token format wrong? We'll break down the most common mistake developers make, passing raw string tokens directly, and show why FastMCP explicitly requires wrapping them in BearerAuth. You'll see the exact correction needed, straight from the official docs, to make authentication work reliably. From FastMCP import client. Async with client. https://fastmcp cloud/mcp. Auth equals your token. As client. Await client ping. This demonstrates an incorrect but common anti-pattern when attempting bearer token authentication with FastMCP2. The code shows a raw string token passed directly to the auth parameter, which the framework explicitly rejects. FastMCP only accepts properly wrapped BearerAuth objects. This incorrect pattern fails immediately with authentication errors, despite appearing syntactically valid. The proper implementation requires explicitly wrapping tokens in FastMCP's BearerAuth class, which handles the correct HTTP authorization header formatting. The framework enforces this pattern to prevent security vulnerabilities from improper token handling, with the context manager ensuring proper connection lifecycle, while the auth class manages credential formatting. This strict separation between authentication configuration and connection management prevents common security mistakes. This distinction matters because FastMCP's authentication system deliberately rejects raw tokens to enforce security best practices. The framework's explicit BearerAuth requirement prevents common vulnerabilities like missing scheme prefixes or improper header formatting. For production use, developers must either use the BearerAuth wrapper or implement custom headers. There is no shortcut for proper token handling in FastMCP2. Let's break it down line by line. From FastMCP import client. This imports the client class from FastMCP, but demonstrates an incorrect authentication pattern. The code passes a raw string token to the auth parameter, which FastMCP explicitly rejects. FastMCP only accepts tokens wrapped in BearerAuth from FastMCP client auth. The correct implementation requires a Python from FastMCP client auth import BearerAuth. Auth equals BearerAuth, token equals your token. This example would fail with an authentication error in production. Always use the documented BearerAuth pattern for proper token handling. Async with client. This example shows incorrect client initialization. FastMCP requires tokens wrapped in BearerAuth, not raw strings. The async with pattern correctly manages connection lifecycle, but the auth parameter here would fail in practice. For proper implementation, use a Python from FastMCP client auth import BearerAuth. Hash auth equals BearerAuth, token equals your token. As documented in the official FastMCP authentication guide. The context manager ensures proper connection cleanup, but authentication must follow the BearerAuth requirement. https://fastmcp cloud/mcp. This example shows incorrect authentication that will fail in practice. FastMCP requires tokens wrapped in BearerAuth, not raw strings. The auth parameter only accepts BearerAuth objects as documented in the official client reference. The correct implementation uses a Python from FastMCP client auth import BearerAuth. Auth equals BearerAuth, token equals your token. The URL follows the required host/MCP path structure, with FastMCP Cloud being the default managed service host. For self-hosted instances, replace this with your MCP server's base URL. Auth equals your token. This shows the incorrect authentication pattern that will fail. FastMCP only accepts tokens wrapped in BearerAuth token equals. Raw strings are explicitly rejected. The correct implementation from the official docs requires a Python. From FastMCP client auth import BearerAuth. Auth equals BearerAuth, token equals your token. I always use this pattern, as it properly formats the authorization header per RFC 6750. Raw string tokens trigger connection failures. As client. This example shows incorrect FastMCP authentication. The auth parameter requires a BearerAuth object, not a raw string token. The proper implementation from official docs uses BearerAuth token equals to wrap credentials securely. The async with pattern still correctly manages connection lifecycle, but this specific example would fail at runtime due to invalid auth format. Always use the documented BearerAuth wrapper for token-based authentication. Await client ping. This example shows the incorrect way to authenticate with FastMCP. The auth parameter requires a BearerAuth object, not a raw string token. This pattern will fail with an authentication error. The correct implementation from the official docs uses a Python. From FastMCP client auth import BearerAuth. Auth equals BearerAuth, token equals your token. The ping call here would reject the string token, making this a non-functional example. Always wrap tokens in BearerAuth for proper authentication. FastMCP authentication pattern. The example demonstrates an incorrect client initialization that would fail in production, as FastMCP requires explicit BearerAuth token wrapping rather than raw string tokens. The auth parameter only accepts properly formatted authentication objects, never plain token strings.
The connection that refuses to begin teaches the most about authentication.